Some sites of exceptional fossil preservation are extremely well known. There are papers everywhere and they absolutely deserve it. But there are others out there that should be better known because they haven't been studied in detail yet, especially ones which are only recently discovered. And there are still a lot more papers that can be written before we can really understand what they're telling us. And one of those is the Llanfallteg Biota of South Wales, which is actually really rather good. Hello and welcome back, or welcome for the first time possibly. I've got over 7,000 subscribers on here now, which is amazing, but there's definitely room for some more. So, paleontology is dependent to a great extent on what we call conservat Lagerstätten. These are the sites of exceptional fossil preservation that preserve things that would normally disintegrate, would rot away, and would disappear from the fossil record entirely. There are a lot of such deposits around the world, everything from famous ones like amber and the Solnhofen limestone of Germany, where you get Archaeopteryx, to the Burgess Shale, and so on. And there are now probably a few hundred conservat Lagerstätten around, which show us little windows into different environments at different times. Some of them are truly extraordinary and preserve basically everything that was alive on the seafloor at the time it was buried, at least down to sort of semi-microscopic levels. And others are much more limited, but still tell us important extra details. So there is definitely a gradation, and some are more important in their general implications than others are. Some are more unique. They tell us more details that we just don't see anywhere else, even if they don't show us the whole community. There's a whole spectrum of different types of conservat Lagerstätten that are all important in different ways. And they're still being discovered. All the time, someone is going out there looking for them and trying to find extra little bits of information that reveal a little bit more of the history of life. So, sometimes when something is discovered, that's actually still the early stages, because it can take a lot of work to really develop and understand what these sites are telling us. And there must be many such sites around the world, most of which I don't appreciate. I don't even know about, because they've not been published or they've barely been published. There may have been one paper somewhere, and because that's all that I have access to, I don't know how good those are. I mean, there are some quite well-known examples where 2 or 3 exciting fossils have been described and then there's been nothing since. So we don't know if there's a lot more to come out or if it was just a few unique specimens. And it's only when you get a bit of an insight from actually having worked on a deposit that you can understand how much more there is that is potentially going to come out from a site that the rest of the world doesn't know about. So this one is a little bit of a glorification of the Llanfallteg Biota of South Wales. This is from the middle of the Ordovician period. And for those who don't know, this follows the Cambrian, when the diversification of all of the major groups of animals seems to have happened. The Ordovician was itself an extraordinary time, and I'm still planning to do a video just on the Ordovician radiation. This is when life diversified spectacularly at lower taxonomic levels. So families, genera, species just multiplied incredibly fast. Ecosystems were restructured, coral reefs and things like that appeared. So the Ordovician is a really important time. And unlike the Cambrian, where we have the Burgess Shale-type faunas basically everywhere you look, well, not quite, but there's a lot of them, in the Ordovician there have historically been really very few conservat Lagerstätten. Up until 20 years ago, we had 2 or 3 that were really sort of considered to be significant. Places like Beecher's trilobite bed, the Soom Shale of South Africa, and there weren't many more. Since then, though, there have been a whole series of new deposits with at least an element of soft tissue preservation, and in some cases spectacular ones. So we now have the Fezouata Biota of Morocco, which is amazing in very many ways. Not complete, perhaps. It doesn't preserve many of the really soft-bodied animals, but it's incredible. We now have Castle Bank, luckily. So this is one I was fortunate enough to find during the COVID lockdowns, and there's a whole video about that. And in fact, most of the members area, for those who might be interested in exploring some extra detail, is about new discoveries and ongoing work on the Castle Bank biota. There are a large number of slightly lesser ones, or ones that are more limited. So other ones around here are Llandegli Rocks and Llanfawr. We also have Anji in China, there's Fenchang in China, there's the Avangam in North Wales, there's Winnesheek, there's the Manitoba sites. There's actually quite a lot now, and they're all telling us about different parts of the fossil record. Many of the Ordovician sites are actually relatively shallow water in comparison with the generally deep water shelf environment, sort of 100 to 200 meters, something like that, of the Cambrian faunas. A lot of the Ordovician ones are either from very specific deep water environments like turbidity flows in the deep ocean for Beach's trilobite bed, or they're from very shallow environments where you have things like almost coastline type areas and very shallow lagoonal type systems from places like Manitoba. So anything that we find in this time of extraordinary diversification and ecological complexification that's going on everywhere is telling us an extra little part of this huge jigsaw, and it's all important. And that's particularly true of the Middle Ordovician, which is when most of this diversification was happening. Now, this one I'm talking about today, the Llanfallteg, was from, indeed, the Middle Ordovician, specifically the Didymagraptus artus biozone of the Darawilian. This is the biozone below the Murchisoni biozone, which is where Castle Bank is. So it's actually very close in age, although the artus biozone is quite long, and this is near the lower part of it, so probably there's something like a 5 million year age gap between the two. And obviously quite a distance, one's in the middle of Wales, one's in the southwest corner, but they are not that far apart in time or space, and they were part of the same marine basin, which is useful because it gives us points of comparison. And we know the age from the graptolites, which are quite easily studied, and Lucy's had a good look at these and pinned down 2 or 3 species, but most importantly we have Didymagraptus artus itself. So we know how old it is, and that all fits perfectly. So when we were living in China in 2012, we received an email out of the blue from someone we didn't know about, we had never heard of before, which we should have done possibly, but we hadn't, a guy called Cedric Connolly. This is an amateur paleontologist who lives in South Wales in the lovely sort of Pembrokeshire area, and he had been going out collecting fossils on an almost daily basis on his dog walks, taking a hammer along, spending 5 minutes or half an hour or an hour until the dog got bored, and hammering in a quarry near his house in Clarbeston Road. This is not an easy quarry to work with.
And if you go over to right to the very other end, you get to the very, very fine stuff, which is next to the cup. So you walk along here, there are some very good specimens. As you go, this gets finer. As you get into this area, what you find is you see there's less, you can see there the rock is finer, and you do find you get better specimens sort of this end.
He'd been doing this for 25 odd years, and it was known to be an interesting site though, because there was a paper published by Harry Whittington in 1993 which doesn't seem to have received a huge amount of attention, but at the time was quite significant, and it just shows the potential of the site, even from that one paper. Because this paper described a fossil that Cedd had found, which was a trilobite. But not your ordinary trilobites, because a trilobite exoskeleton is made of calcite. This is the dorsal exoskeleton. The rest of it, the underside, the legs, the antennae, all the rest of that, are all made of chitin, and trilobites basically rot away. You just get the exoskeletons left. And it was actually thought in historical times that trilobites didn't have any legs. They just sort of glided around like hovercraft. And it was perfectly reasonable until you understand fossil preservation. So because of the calcite skeleton which preserves and the lack of preservation of everything else, it looked like they had no legs. But every now and then, people have found sites like Beecher's trilobite bed where you do get the soft tissues of trilobites preserved. And there are not many sites like this around the world. It's still quite a rare thing. Even in places like the Burgess Shale, there are many species of trilobite that are known there which have never had the soft tissues preserved. It just seems to be fairly rare. And what Cedd had found was one with a great big pair of antennae sticking out the front. And also a gut going down the middle. Because why not? And this is not just the chitinous preservation of the antennae, but also soft tissue preservation of internal organs. And you see something like this, you get excited. And so did Harry Whittington, and this was actually written up, and it was an important find. And when something like this turns up, you have no idea whether that is the end of the story, or whether there's a lot more that's going to be coming out in future. So remember, that was 1993. I didn't hear about that paper particularly, for some reason. Just didn't cross my radar. Should have done, given I was working Wales at that time, more or less. Just starting work, really. But then there was nothing else following it until 2012, when I received, or Lucy and I received, this email out of the blue showing photographs of something quite remarkable. And it turns out that Cedd had been quietly hammering away for decades, putting aside interesting specimens, building up a collection, and it was only when this thing turned up that he decided to reach out to several people, as it happens, and actually get it seriously studied, because at that point you knew it was going to be good. 25 years collecting this stuff. That is dedication. And it's a seriously good eye that's needed, and a lot of persistence and sheer enthusiasm, because it's so important not to overlook all of the work that goes on by amateur collectors who are spending their lives not necessarily describing, not publishing papers, but acquiring all of the information that allows this knowledge to come to light. And Cedd has been extraordinary, not only in his ability to find these things and his persistence, but just his willingness to share it all. So his material has been going to the National Museum in Wales. He brought us and Martin Brazier, then just about retiring professor from Oxford, in. And it was just wonderful to see what he'd been doing. So, yes, hello, Cedd. I know you get embarrassed by the plaudits, but you deserve them. So, one thing I've got to say to start with is that this is a difficult place to work. In fact, what Cedd had been doing is picking up loose bits from around the base of a very tall and slightly unstable cliff in an old quarry. The rock is hard. This rock has been cooked. It's in the slightly metamorphic zone. It's slightly sheared and cleaved. It's definitely been a bit compressed. It's not in its perfect, pristine state. And it has been baked. So this rock takes quite a lot of hammering. And if you were to hammer this cliff directly, it would not be a wise thing to do, because this is a tall cliff. This cliff goes up quite a long way and bits fall off it. It's also had lots of trees growing up around the base. It's not an easy place to work. And the beds here, to make matters worse, are basically vertical. This is an area that has been part of this continental collision zone between Avalonia, this continent of England and Wales and a few other bits, and Laurentia, which is Scotland and North America. And so it's part of the crumple zone, and the rocks have been folded and faulted, and in places they go vertical. And this is one of those sites. The fossils are mostly found in a relatively narrow interval, so that is a vertical band going up the cliff and going across the floor of this quarry, which has been long owned by the council, used for storing chippings for roadworks and that sort of thing. So that is also very difficult to do. You can't really hammer down into it, at least not easily. And it is hard to get much out. It was this one fossil that was found to start with, but after that, Ced realised just how important this was, and there were lots of other fossils that had been turning up over the years as well. Fairly ordinary things like graptolites, and lots more trilobites, and lots of other things that had preserved a sort of black material on the rocks. And some of these, it turns out, are quite exciting. In order to find more fossils, Ced actually resorted to digging a little trench across the quarry floor in this interval where the fossils were coming out. This was hard work, but I'll let Ced explain it to you himself in his wonderful South Walian accent.
This is a trench which I opened up several years ago, and in this trench I found some very interesting specimens, one which was an echinoderm. Another looked like the underside of a trilobite or some arthropod, plus a few other specimens which intrigued me. Unfortunately, I could only go down so far because I only had a hammer and chisel, and secondly, because this place is used to store chippings, I had to fill the trench up afterwards. But one of the distinctive features of this trench, you will come across a rock, a rock which is fairly blue, and you tend to find the interesting specimens in the bluish rock rather than the grey rock which is surrounding the ground here. Unfortunately, it's a hit and miss affair. You will not find the specimens right along the band. If I can find my chisel, right, or the two chisels. Yeah, what's interesting, you see grey there, blue in the middle, and blue tend to be on the other side. So it's obviously in here, and we should jump out and say, look, hello, here I am.
So it's the blue stuff that has the good
yeah, the stuff that went. That's right. That's the stuff that tend to find more stuff. You know, it's.
So that was a hand-cut trench by Ced, but the fossils are not abundant, even so, and there's a limit to what you can get out of that with quite a lot of hard work, chiselling your way into the floor of the quarry. So once we had people like Martin Brazier involved at Oxford, and he had a student, Tom Hearing, we brought in David Legg as well to work on arthropods, we actually ended up with opportunities for doing more. And the only way to find significant numbers of fossils in a situation like this is to get out quite a lot of rock. And that requires an excavator. And, an excavator duly happened.
The trench has been dug. The material has been placed in fact, 3 different places. The trench, which is at right angle to the main trench, has been placed in this location there,
so that the
which is the
pile.
first pile of rocks.
Okay.
The material from the actual trench itself has been brought back to my place, and also it's been also placed in that first pile,
Okay, nearest the gate.
nearest to the gate.
Great.
So the right angle, the rocks from the right angle is the big pile there. There is also a pile of rocks which is over here, and this pile here is in fact from this end of the trench. Rather than take it over by the gate to the first sort of pile of rocks, we thought possibly best to keep it here. What I would be interested to know, what happens when it rains heavily? We have a nice pond for all these frogs. We can make it into a little wildlife pond.
The end result of that was a paper in 2016 by Tom Hearing et al., quite a lot of us in the end, and where we described a few of the fossils and just drew attention to the existence of this soft-bodied fauna. And one or two of these you've seen before, so here is a rather gorgeous paleoscolecid, which is currently being written up. So this one, there's a manuscript that's actually getting fairly close to being submittable now, and we've done quite a lot of work with electron microscopy, and it is a very, very nice worm, which is also quite interesting. But that one hasn't been published yet in detail. It's this one, obviously, at the top right. There are other things that have been written up as well in separate papers. So this is an arthropod, the one that sort of triggered all this new phase of the search. This is part of another arthropod. This is a sponge, rather a nice one as well. And I'm also working up the rosselids that I mentioned in another video quite recently, and that paper is also not that far away from being submittable. But none of the rest of these fossils have been published separately yet. There is some gut preservation in a different trilobite. This is Selenopeltis. There are other bits with bits of legs and so on. There is a starfish, a poorly preserved one. It's lost most of its arms, but it's still interesting. There is probably, we think, a soft-bodied worm with a couple of tentacles at the front, an annelid of some sort. This we published not quite knowing whether it was arthropod or worm. One with sort of paddles on the side, like various annelids do today, or something like an arthropod which has sort of swimming flaps. Now, there have, since this has been published, been other things described which make it much more likely, I think, this is an arthropod. So we have paleoscolecids, which are a very common group in the Cambrian and also fairly widespread in the Ordovician, so not unexpected. But those arthropods, they're quite intriguing. Now, that long sort of spiny thing, which ended up being called Dronewinia, is part of a marrellomorph, a marrellid arthropod related to the so-called lace crab of the Burgess Shale. And this is quite a lovely sort of animal. They were first described from the Burgess, I think, not totally sure now actually, because they are also known from the Ordovician and even the Devonian, from various sites in Morocco and Bohemia. And it's one of these classic Burgess Shale-type organisms, although we don't use that phrase anymore, do we? As some of you who have been watching some of the previous videos recently will know. But it's still something what was characteristic of the Burgess Shale, but also carried on a long time later. So that also doesn't tell us that much. But then there was Etania howelzorum, which unfortunately the name is going to have to be changed because Etania is also a moth, and that has priority. Unfortunately somebody didn't check the pre-existence of that genus name, so it's going to have to be reassigned to a new genus at some point. But it is an incredible fossil. It's an arthropod. It's got great big sort of spiky appendages around the mouth for catching food and presumably crunching it up. It's got a series of lateral sort of flap-like structures which include gill filaments. It's actually got the gills preserved in this thing. And then you've got the whole body is not quite entirely preserved, but down to the tail region where you've got this sort of cetose tail flap as well, paddle-like structures. And it's a remarkable thing. And it was described as a xenopod. And this is a group that includes various Cambrian Burgess Shale-type arthropods, such as, this is where the, I'm going to have to check the current taxonomy because I think it's changed a bit, but Sanctocaris was one of the comparisons that was being made. They actually thought Sydneya and Emeraldella from the Burgess Shale were the most closely related, but also compared with a few other things, from Chengjiang in particular, Vetifaces and so on. So there are features which are shared with other Cambrian arthropods, but this was a group that was otherwise basically not known from after the Cambrian. So this was again a surviving member of one of these early lineages of stem group something or other within the arthropods. And the implications of this were considered to be supporting previous information about the Fezwata biota, also preserving lots of Cambrian-type arthropods, but that was in a near-polar environment, very cold water near the South Pole. Llanfallteg is deeper water. It's not polar, it's temperate, but it is from a relatively deep part of the Welsh Basin. The trilobites are mostly blind species. Not entirely, but mostly they are blind things like Placoparia, which have no eyes. So at this point you know that it's probably below the photic zone. Otherwise things without eyes would be at a disadvantage. There's also quite a lot of transport of specimens from shallower water into this environment. There's a lot of downslope slumping and so on. And we see this also with things like the starfish, which were evolving in shallow water at this time. It's quite early for starfish, but they were around at this time. And that was a poorly preserved one. It's damaged, it's lost a few bits of the arms, and it was almost certainly living in shallow water. So we have a mixed assemblage coming in of transported shallow water things and things that were living in the deep water and are better preserved. So probably most of the soft-bodied animals are living in the deep water environment where the burial was happening, whereas some of the shelly stuff, the more typical fossils and the more fragmentary ones, are being washed in. So how deep are we talking about? Well, below the photic zone and into the what we call the athaloptic trilobite assemblage of these mostly blind things with pelagic ones, it's probably 200 meters and a bit more at a guess. It's probably not going to be enormously deep. We're not way out in the middle of the basin. There were volcanic islands obviously nearby, like in Bilthinlayer, because we got huge great volcanic ash beds. So most likely we're looking at something around 200, 250 meters, something like that. Maybe a little deeper, unlikely to be shallower. And that means that we've potentially got survival here of Cambrian lineages in deep water as opposed to in cold water at the poles. And that fits the general pattern. It's long been thought that very deep water, it acts as a sort of refuge for things that are being evolutionarily outcompeted in shallow waters. So that was the main part of the story with the Llanfallteg biota. It was the discovery of some Burgess Shale-type organisms, the phrase was still being widely used there. It should be discouraged now, as I say. But some of these lineages that evolved in the Cambrian and then carried on for a while, in an environment that was relatively deep water, when they hadn't been found in the shallower water, at least non-polar environments elsewhere in the world. So it kind of makes sense. It fits the paradigm that we had at that time. That paradigm is now changing. Castle Bank, for example, is much shallower and also includes some Burgess Shale-type elements, if you like. So there's a lot more to this story than we knew about at the time. Also, it's worth noting the sponge that's been described so far as a Pyreneid. This is also a typically Cambrian group, but we now know that they survived in multiple continents through the Ordovician. So this is actually the same genus as one that was described from the Llanfallteg Biota. It's now in Oreopyrenea rather than Pyrenea, and it's very closely similar in some ways. So we have prolonged survival of some of these, what used to be thought of as Cambrian lineages, through the Ordovician, the more exceptional preservation we find. But this was quite a small paper, and that was about all that we've actually ended up publishing. Part of the problem was that, tragically, during the process of publishing this, our good friend Martin Brazier, who had only got to know on this project, but who was a wonderful man, was killed in a car crash shortly after retiring and moving to South Wales. And it was one of those tragic accidents. Someone else fell asleep at the wheel. And it was just, well, it was kind of devastating for most of us, and the project just completely slipped. So CED has still been carrying on, and there has been a lot more in the way of fossils being found, hence these new Rosellids, and we're hopeful now that this will be sort of picked up a bit more, and there will be more papers coming out, because there is still a lot more to describe. I think most of the best specimens have already been at least illustrated in this paper, but there are a lot of other things there as well, and that's all part of what this site can tell us. So I'd like to give you a little bit of a flavour of that, with a bit of a rogues gallery of some of the other stuff that is still out there and yet to be written up, and which shows the potential and the level of preservation and the actual diversity of this site. Enjoy. Unexpected interlude. I just got damp. there was, I think it was water falling out the sky. Which, yeah, okay, this is Wales, but we haven't seen that for about 2 months. The hills are all brown and there seem to be wildfires everywhere all over Wales at the moment. So this is an unusual summer, and our gardens really, really needed it, as did everything. So, yeah, we've actually had some rain. It lasted about 5 minutes and counted as a small shower, but it's a start. Anyway, where was I? Yes, Llanfallteg. So the question is from all this, what can this deposit really tell us? What is its potential? Why am I so attached to it? Partly because, of course, it's one that I get to work on and I know the discoverer and all the rest of it. But even so, there's a lot here, and it's unusual in representing a relatively deep water environment with quite a diverse fauna. So diverse as in lots of different groups rather than lots of species. I mean, Angie is deeper and has more species, but they're almost all sponges. Here we have apparently worms, arthropods, echinoderms, sponges, cnidarians. We've got a lot of different things. And the soft tissue preservation is actually, at its best, it's really very good indeed. It's like the Cambrian faunas in terms of the level of detail, the gill filaments, apparently soft-bodied worms. It's actually got a lot of indicators of a really, really good fauna. The difficulty is just that it's so hard to excavate, and that so far there hasn't been enough published to really justify much more work going on. So at the moment, this has been a sort of a one-man show in KED actually finding all this stuff. And then there was that brief interlude when we had a bit of an excavation. But there is a lot of potential, I think, for doing more than that if there was permissions and all the rest of it for a larger excavation, which would have to cut further down. It's difficult because it's a narrow band going vertically downwards or into a vertical cliff. So it's not the easiest sort of fauna to work with. But even so, there's already quite a lot there, and I suspect there's a lot more to come out if only we were to be able to actually get to it. And what it is likely to be telling us is partly about groups of Cambrian type animals, things that are known from the Cambrian Burgess Shale-type faunas, which probably did survive in deeper water rather than in shallow water. That almost certainly is a factor. It's something that probably happened, despite the fact that we are now getting more and more of these apparently Cambrian lineages turning up in shallower water environments in the Devonian as well as the Ordovician. Although a lot of them did survive, clearly, it is probably likely that many of them did survive in the deeper water. So we might get a much better window into that from this particular deposit. At the same time, you've got the mixing from these shallow water things. So we may get surprising things being washed in and preserved as part of this assemblage from the shallow water communities. The question is what detailed information we can get out of each fossil, because there are so few of the really good fossils that you have to make the most of them. But I have no doubt that it's entirely possible to do just that and to actually understand this and slot it into its place in Ordovician paleontology. It is a significant part of the jigsaw, and because the preservation is just so good, it is possible that we will get completely soft-bodied things. Well, we already are, some of those worms, for example, but preserved in such a way that we can get a lot of information out of it. So there we go. Keep going, Ked. And everyone else who is working in this area, please do pay attention to it, because there's a surprising amount there. And hopefully in future, more people will come to be working on this site and we'll end up with a really thorough understanding of what is going on in this little quarry in a tiny little village in southwest Wales, which has been there a long time, but nobody noticed these fossils. It's the old familiar story. Unless you have the right person on the ground to see them and recognise them, they're not going to be discovered. So what else is there out in the middle of Wales? Or on the edges? Or in the coasts? We just don't know. And not just Wales, of course. Anywhere there is the potential of finding extraordinary fossils if you have sedimentary rocks. It's just a question of going out and looking. So there you go. I hope you've enjoyed that one. A little introduction to the Llanfallteg Biota. And it is something that deserves some attention. I'll leave it there for now and get on to probably a couple of ones about papers that have come out recently. So there's interesting news stories appearing at the moment. And yeah, I'll work out what I'm saying about them in due course. There'll be something else for the members soon as well. We've got another good one from Castlebank. Bye for now.